So wait, what is it? This thing's 312, right?
Right.
Okay.
And then it's 10 meters long.
Okay. So it's 10 meters. Does it say what about this sign? Like how much it weighs or something?
215 kilograms.
Okay. Okay, and then let's see. Is that an angle right there?
Yeah, 35.
Okay. Okay, so we want this tension.
Oh yeah, it also says that the cable is 6 meters.
Long?
Yeah, I think it, like the, actually. No, the distance between,
Oh.
the, not the hypotenuse, but the...
This is 6 meters?
Uh-huh.
Okay. Okay, so we're looking for this tension, right?
Yeah.
Okay, so let's just like draw out the other forces. So we're gonna have a force from this like sign pulling down, right?
Mm-hmm.
And there's gonna be like a force from this beam pulling down. So we got something like that. It's kind of like the forces on it. So we're gonna pick a pivot point.
Okay.
So we're just gonna pick this right here, because this problem is gonna be like a sum of the torques is 0 since it's just sitting still. It's at equilibrium, and sum of the forces is 0 too. So if we pick this point, we're just gonna look at these 3 forces.
Okay.
And how they act based on this pivot point. So we can just pick this as like torque 1, torque 2, and torque 3. Oops. Okay, so torque. Do you remember the equation for torque?
Yeah, it's force times R.
Uh-huh. Yep. And then cosine theta too. And that'll be important for this one. Okay.
Sine theta?
Oh, yeah, it is, huh? Thanks for catching me.
Yeah.
That threw me off, yeah. Oh, it is, because if you look at this angle right here, you want this side of it. So yeah, it's going to be sine, because you want the opposite. Yeah, thanks for that. Okay, so... Okay, so let's see. So next we just need to like write out an equation for this. So we're just going to basically look at like all the different torques, right?
Yeah, okay.
So, let's just say like these torques going down are going to be positive, and the one going up this one's negative.
Okay.
Doesn't really matter. All you really want to see is if these torques make it go clockwise, which these both do. And this torque, if you were to push, or this is the pivot point, and you were to push here, this would make it go like counterclockwise.
Okay, so torque 1 and 3 are both
Positive.
Yeah.
Yeah, because they're both going clockwise. So you can say clockwise is positive. It doesn't really matter how you label it, just as long as you keep it. So we're going to say like torque 1 minus torque 2 plus torque 3 is equal to 0. And so now we just need to write it out. So if we since what we're trying to solve for is torque 2, well, we're trying to solve for the tension.
Yeah.
Which is part of torque 2. So we're going to just add it to the other side. So it's like torque 1 plus torque 3 equals torque 2.
Okay.
Yep. Then we can just sort of fill in the gaps. So we have like force times r sine of theta for 1. This is actually mg plus mg r sine theta equals. This one, the force is tension, right?
Mm-hmm.
Times distance times sine of the angle. And then we're just going to divide everything by r sine theta. So we just end up with, that's what the tension's equal to.
Okay.
So now you just kind of got to fill stuff in. So I'm going to write it over here. So mgr sine, this is of torque 1, right? Which is this. So what am I going to put in for, let's just look at what torque 1 is. What am I going to put in for those numbers?
So 10, 9.8.
Yep, so 10. Well, it's going to be halfway from 10.
Oh,
So it's going to be 5, right?
yeah.
Because we're looking at the distance from here to here.
Yeah.
Yeah, so, yep, so, right, 5 meters. Yep, 9.8 times the weight, right? 310, 312. Actually, sorry, I measured in there. And then sine, it's just of 90 degrees. So it's just going to be 1, so we don't have to worry about that. But yeah, I guess.
Okay, and then.
Okay, so what about this? This is torque 3.
So.
So should we put in for torque 3?
215.
Yep.
9.8. And then 10.
Yep.
And then would the angle be the, oh, it's 90.
Yeah, it's just 90 because it's still going straight down.
Okay.
Yep. Okay, so for this last part, now we just need the distance here for torque 2. And we need sine of this angle right here.
Okay. It's like my button doesn't really work. Okay.
Okay, so 6 meters for the distance, right, from here to here.
Yeah.
And then, okay, so if we look at this thing, this is a right triangle. So we have 35 up here. So that means we have 55 right here.
Mm-hmm.
So we're just going to put sine of 55 for this angle. Because that tells us what this side, what this is right here. Which, this like y component is what we're most interested in. That's really what's like giving it the push. Because the x component just doesn't really matter, so that's why you do a sine of that angle. Yep. So you just plug it in and solve for the tension.
Okay.
Yep.
Do that.
Cool.
And then the next question asks what the force is at point P.
What's point P?
The where you drew
Right
this,
here?
Yeah.
It's gonna be something like that. Okay, so it wants what this force is, right?
And let's see. Yeah, magnitude and direction.
Okay.
So on the angle too.
Okay. That sounds good. Yeah, it's gonna be kind of, I don't know, it'll be going this way and probably maybe a little up too.